Next up here in this first section in Chapter 2 is how we're actually going to use the fundamental identities to deal with certain types of problems. They mention here that one of the most common types of applications for these is to use given values to evaluate the remaining trigonometric functions. This is something that I had you guys do as part of Exam 1 on that very first question. I gave you one value for one of the trig functions, told you what quadrant you were in, and you had to find the remaining 5 trigonometric values. We were capable of doing it then, and we should be even more capable of doing it now, given that we have more of these identities at our disposal, and we've started to manipulate them to make them very, very efficient at finding these remaining values. There's lots of different paths we can take. I should mention up front that this section and the next section are easily some of my favorite parts of trigonometry. This is where we get to do a lot of critical thinking rather than having to do a bunch of rote arithmetic. The idea here is, how best can I arrive at the answer I'm looking for with the tools that I'm given? This is a lot of problem solving and critical thinking, so kind of keep that in mind as we build to these different parts. Now I'm going to go ahead and pop over to the notepad to give us our first problem here. The problem that we're going to work actually shows up in these slides as well, but I don't want to spoil the answer as we work through it, so I'm going to go ahead and do this separately and have you guys follow along. So for this particular problem, we're given one piece of information up front. We're told that secant of our angle U is going to be equal to negative 3 over 2. And the second piece of information we're given is that tangent of U is less than 0. Now this particular piece of information may not seem that important, but let's think about what's going on right now. Here we have secant is negative, and according to the information, I should change this really quick. This should be tangent is greater than 0. And from what we've been told here, tangent is positive. So think about what quadrant that means that we're going to be in. We've talked about this before. There's that mnemonic device, all students take calculus. So in this first quadrant, all of our trigonometric functions are positive. That's not the case here. Here our sine-based functions are positive. Well, that's not the case. Here our tangent functions are positive. So tangent is positive, and a cosine function, because it's secant is the reciprocal of cosine, is negative. That means we're in quadrant 3. So let's just make a note of that for future reference. This is going to tell us that our tangent and cotangent value should be positive, but our secant, cosecant, sine, and cosine values will all be negative. We've already gotten one huge chunk of information just off of these two pieces that they've given us. Now we still need to go ahead and work to find the remaining parts. So let's talk about how we can use our identities. We have that the secant of U is negative 3 over 2. So let's start by using our reciprocal identity in that case. If secant of U is negative 3 over 2, then cosine will be the reciprocal of that. So cosine of U will be negative 2/3. Now that we have this piece of information, where should we go to next? Well, one of the things that I like to do is once I have either cosine or sine is I like to go ahead and go to my Pythagorean identity. Sine squared U plus cosine squared U equals 1. And we'll solve for the missing part. So we have sine squared U plus, I'm going to replace cosine with its value, so this will be negative 2/3 squared. We talked about this before, but a trigonometric function squared is the same as the value of that trig function squared, so that's why we have it here, equals 1. Alright, so this is going to end up being positive 4/9, which I'm then going to subtract from both sides. 1, which can be thought of as 9/9 minus 4/9, is going to give me 5/9. So I have sine squared U equals 5/9. I'm going to take the square root of both sides. Now this would normally give me plus or minus, but since I know I'm in quadrant 3, I know that I want the negative value. So sine of U is going to be negative square root of 5 over 3. So look at that. We've already got 2 of our remaining trig functions down. And with a quick use of a reciprocal identity, we can find the value for cosecant as well. So cosecant would be the reciprocal of this value, keeping in mind here that we want to rationalize our denominator. So cosecant of U would give us negative 3 over the square root of 5, but I don't want to leave that square root down there. So I'm going to multiply the top and bottom by the square root of 5 to turn this into negative 3 times the square root of 5 over 5. And then from here, let me just go ahead and add it to the collection. 3 down, only 2 left to go. And for the last 2, there are a couple different approaches. You'll actually see with some of the examples used in the slides and in the textbook that they find tangent and cotangent using some of the Pythagorean identities or using reciprocal identities. We're just going to use the quotient identities in this case to make it as easy as possible. And use the fact that, again, since we're in quadrant 3, we know that both tangent and cotangent are going to be positive. So let's start with tangent. This will be a quotient of our sine and our cosine, specifically sine in the numerator and cosine in the denominator. Since they have the same denominator, we can ignore that. They have the same sign, so their quotient will be positive. This will be the square root of 5 over 2. So in this case, it's just our sine value over our cosine value with a lot of simplification done in advance. That leaves us with cotangent to round out the set. We'll use the fact that it's the reciprocal of tangent. So this will be 2 over the square root of 5. Don't want to leave that square root of 5 in the denominator, so we rationalize it to 2 times the square root of 5 all over 5. And there you have it. With a little bit of thinking here, we've gotten all of our remaining 5 trigonometric function values. Let's talk about the procedure. First, we use the 2 pieces of given information to identify what quadrant we were in. Following that, I used a reciprocal identity to give myself 1 extra trig function straight away. From here, I used a Pythagorean identity to find another trig function value, and then I used a reciprocal identity to again find a third trigonometric function value. At this point, I recognized that I had both sine and cosine, so I used a quotient identity to find tangent, and then used a reciprocal identity to find cotangent. So off the side, I'm going to write them out here. We used reciprocal to find cosine, We used Pythagorean to find the value for sine. We then used reciprocal to find cosecant. We used quotient to find tangent, and then we used reciprocal to find cotangent. We have all these different identities at our disposal, so we just want to go ahead and take the path of least resistance. That might differ for you compared with another student in the class. So always be thinking about what makes the most sense to you based upon the information you've been given, where you want to go, and the quickest route to get there.